In this video, we have a quick recap of Module 1, that is the Introduction to User Interface Design. So in this module, we shall be discussing some important points such as importance and benefits of good user interface design, the characteristics of graphical user interface, similarly the characteristics of web interface, and the general principles of user interface design, along with the differences between the graphical user interface and the web page design, followed by the indirect and direct manipulation of graphical systems, and the characteristics of intranet as well as internet. So we begin our discussion with the importance and the benefits of a good user interface design. So before we move on to the benefits or the importance of a user interface, we shall first define what exactly is the meaning of a user interface design. So basically, user interface design is a subset of a field of study called human-computer interaction. Human-computer interaction is the study, planning, and design of how people and computers work together so that every individual's needs are satisfied in the most effective way. So basically, a user interface is a part of a computer itself, and it's a software that the people can see, hear, touch, talk to, and otherwise understand or direct. So basically, user interface essentially has two components to it. One is the input and the output. So by input, we mean it is how people communicate their needs to the system using keyboard or any other pointing device. And the output means it is how the system returns the processing results to the user, either through the screen or sound. The best interface is the one which has proper design with combination of effective input and output mechanism. So in spite of today's rich technologies and tools, we are still unable to provide effective and usable screens. Why exactly? What could be the possible reason for it? Is it so that we don't care for a good interface design, or don't we possess enough common sense to design a good interface, or is it that we face lack of time and care, or is it that we really do not know how to design a good interface? So, a well designed interface and a screen is terribly important to users as it is their window to view the capabilities of the system, and it is also a vehicle through which complex tasks can be performed. A screen's layout and its appearance affects a person in varieties of ways. If they are confusing and inefficient, then naturally people will have a greater difficulty in doing their jobs, and which will lead to making more mistakes. So, a poor design may even chase some people away from the system permanently. So, it can also lead to frustration and increased stress. So, therefore, a good interface design becomes almost essential. So now let us look into what are the benefits of a good design. The very first one is the productivity. The benefits of a well-designed screen have also been under experimental scrutiny for many years. One researcher, for example, attempted to improve screen clarity and readability by making screens less crowded. So the result of it was the screen users of the modified screens completed their transactions in almost 25% lesser time with very few errors than those who used the original screens. So therefore it a good interface design enhances the productivity. So then one more advantage here is the reduced training costs. So, another researcher reported that reformatting inquiry screens following a good design principles reduced decision making time by almost 40% and resulted in saving 79% years in the affected systems. So, other benefits also occur from good design. Training costs are lowered because training time is reduced, and the support line costs are lowered because fewer assist calls are necessary, and the employee satisfaction is increased because of the aggravation and frustrations being reduced. So, another benefit is ultimately that an organization's customers benefit because of improved service they receive. And similarly, identifying and resolving problems during the design and development process has also significant economic benefits. Now we move on to characteristics of graphical user interface design. So, a user interface is a collection of techniques and mechanisms to interact with something. What the user interacts with is a collection of elements usually referred to as objects. They can be seen, heard, touched, and the objects are always visible to the user and are used to perform some task. They are interacted with as entities independent of all other objects. So, people perform operations called actions on these objects, and the operations may include accessing and modifying the objects by pointing, selecting, and manipulating. So, a graphical user interface design is a collection of different objects properly arranged on the screen. So, the success of any graphical system has several factors. The following have been commonly referenced in literature and endorsed by their advocates as the advantages of these systems. Thus, the success of graphical systems has been attributed to a host of factors. So, now let us look into the advantages of the graphical systems. So, basically, graphical system consists of a set of symbols. Therefore, symbols are recognized faster than text. So, symbols are more accurate than text. For example, a good classification scheme that speeds up recognition is the icons. These icons allow speedy recognition of the type of message being presented. Similarly, it also enables faster learning. That is, a graphical or a pictorial representation aids learning and symbols can easily be learned. Similarly, Faster use and problem solving is the another advantage. The visual or the spatial representation of information has been found to be easier to retain and manipulate and leads to faster and more successful problem solving. And the graphical systems are easier for remembering too. Because of its greater simplicity, it is easier for casual users to retain the operational concepts. And it's more natural. The symbolic displays are more natural and advantageous because human mind has a powerful image memory. And graphical systems lead to very few errors because the reversibility of actions reduces the error rates because it is always possible to undo the last step. Error messages are less frequently needed. Similarly, increased feeling of control. So the user initiates an action and feels it is in his control. This increases the user's confidence while he utilizes the graphical user system. So immediate feedbacks. Graphical systems can offer us immediate feedbacks. The results of actions furthering user goals can be seen immediately. If the response is not in the desired direction, the direction can quickly be changed. And in such systems, it's very easy to predict the system's responses. So, predictable system responses also speed up the learning. And then it's more attractive because direct manipulation systems are more entertaining, clever, and more appealing. And it may consume very less space, such as icons may take up very less space than the equivalent in words, but it is not the case always, anyhow. And these icons have a capability of replacing the national languages. That is, icons possess much more universality than the text and are more easily comprehended worldwide and easily augmented with the text displays. Where graphical design limitations exist, direct manipulation systems can easily be augmented with the text displays, whereas the reverse is not true. And it requires low typing, that is, pointing and selection controls are such as mouse, trackball, eliminate the need for typing skills. Though we have seen a set of advantages of graphical systems, there still exist some disadvantages too. So, among these disadvantages are the very first one, the greater design complexity. That is, the controls and basic alternatives must be chosen from a pile of choices numbering in excess of 50. This design potential may not necessarily result in a better design unless proper controls and windows are selected. A poor design can undermine the acceptance, and learning still is necessary. The first time one encounters many graphical systems, what to do is not immediately obvious. A severe learning and remembering requirement is imposed on many users because the meanings of the icons or the pointing devices used have not been learned by them. And similarly, lack of experimentality derived design guidelines. So, today there is a lack of widely available experimentally derived design guidelines. Earlier, only few studies to aid in making design decisions were performed and were available for today now. Consequently, there is too little understanding of how most design aspects relate to productivity and satisfaction. So many different techniques, terminologies, and look and feel exist among various graphical system providers and even among successive versions of the same system. So the user has to learn or relearn again while shifting to the next terminology. So it leads into this is all happening because of inconsistencies in the techniques used and the terminologies. And sometimes the symbolic representations may not be as familiar as words or numbers. Numeric symbols elicit faster response than graphical symbols in visual search tasks. So therefore, the job is not always similar. Window manipulation requirements are also still excessive and repetitive. That is, window handling and manipulation times are still excessive and repetitive, which wastes time. There is also production limitations. The number of symbols that can be clearly produced using today's technology is still limited. A body of recognizable symbols must be produced that are equally legible and equally recognizable using different technologies. This is extremely difficult as of now. Few tested icons exist. So, icons must be researched, designed, tested, and then introduced into the marketplace. The consequences of designing a poor or an improper design will be leading us to confusion and may also sometimes lower the productivity of the users. Similarly, for an experienced touch typist, the keyboard is very fast and a powerful device. And there still is a lack in efficiency for touch typists. Sometimes graphical systems are inefficient for expert users. Like not all users prefer pure iconic interface. Users sometimes also prefer alternatives with textual captions and not always fast and it is not always a fastest style of interaction. So graphic instructions on an automated bank teller machine were inferior to textual instructions. This is just an example. So sometimes it, graphical systems tend to be inefficient for expert users and they may also consume more screen space. Not all applications will consume less screen space. A listing of names and telephone numbers in a textual format, for example, will be more efficient than scanning every card file, right? So sometimes it's like not all graphical user interface systems may consume lesser screen space. So there also exist hardware limitations. That is, a good design may also require hardware of adequate power, processing speed, screen resolution, and graphics capability. Moving on to characteristics of graphical user interface. Thus, a graphical system possesses a set of defined concepts which include sophisticated visual presentation, So, visual presentation is the visual aspect of the interface. It is what people see on the screen. So, sophistication of a graphical system permits displaying lines, drawings, and icons. It also permits displaying of variety of character fonts with variety of different styles and sizes, and millions of colors could be displayed on the same screen. And the graphics also permits animation and presentation of photographs and the motion videos too. The meaningful interface elements visually presented to the user in a graphical system include windows. So the windows could be primary windows, secondary windows, or they can also be the dialog boxes. Similarly, it also has menus, so it may include menu bars, pull down, pop ups, cascading icons, and it may also have icons to represent objects such as programs or files. It may have screen based controls such as text boxes, list boxes, combination boxes, scroll bars, buttons, and mouse and other pointing devices as well as the cursor. So basically the objective is to reflect visually on the screen the real world to the user as realistically, meaningfully, simply and clearly as possible. So then pick and click interaction. Elements of a graphical screen upon which some action is to be performed must first be identified. The motor activity required for a person to identify this element for a proposed action is commonly referred to as pick, and the signal to perform an action is referred to as click. The primary mechanism for performing this pick and click is most often the mouse and its buttons. The user moves the mouse pointer to a relevant element or an object, picks it, and then signals an action which is nothing but performing a click operation. So, rapid pointing allows rapid selection and feedback. The eye, hand, and mind seem to work smoothly and efficiently together here. And the secondary mechanism for performing these selection actions is the keyboard. Most systems permit pick and click to be performed by using the keyboard as well. And then restricted set of interface options. The array of alternatives available to the user is what is presented to him on the screen, or what may be retrieved through what is presented on the screen. So it could be nothing less, nothing more. So this concept fostered the acronym what you see is what you get. And then the next characteristics of GUI is visualization. So visualization is a cognitive process that enables people to understand information that is difficult to perceive because it is either too large or it is too small or abstract. It involves changing an entity's representation to reveal gradually the structure or the function of the underlying system. Presenting specialized graphic portrayals facilitates visualization. The best visualization method for an activity depends on what people are trying to learn from the data. The goal is not necessarily to reproduce a realistic graphical image, but to produce one that conveys the most relevant information. Effective, effective visualizations can facilitate mental insights and increase productivity and foster faster and more accurate use of data. And then we have object orientation. So as we already know that a graphical system consists of objects and actions. Objects are what people see on the screen. They can be manipulated as a single unit. A well designed system keeps the user always focused on the objects and not on how to carry out the actions. But whereas objects can be composed of sub objects in itself, so the documents sub-objects may be for example, if you consider a document to be an object, then you can consider paragraph, sentence, words, etc. to be its sub-objects. So container objects are the objects that hold other objects. They are used to group two or more related objects for easy access and retrieval. So there are three different kinds of container objects such as workplace, folders and work areas. So basically you can think of workplace as a desktop. It's a storage area for all the objects, and folders are general purpose containers for long term storage of these objects, and work areas are temporary storage folders which are used for storing multiple objects that are currently being worked on. Device objects represent physical objects in the real world, such as printers or trash cans. These objects may contain others for acting upon. So, a collection is the simplest relationship, the objects sharing some common aspects. So, a collection might be result of a query or multiple selection of the objects. So, a constraint is a stronger object relationship. A composite exists when a relationship between objects becomes so significant that the aggregation itself can be defined as an object. So, for example, including a range of cells into a spreadsheet or a collection of words organized into a paragraph. So another important object characteristics is persistence. So persistence is maintenance of a state once it is established. An object's state should always be automatically preserved when the user tries to make a change to it. So similarly, use of recognition memory. So continuous visibility of objects and actions encourages the use of a person's more powerful recognition memory. This eliminates the out of sight, out of mind problem. Concurrent performance of functions. So, graphical systems may do two or more things at one time. Multiple programs may run simultaneously. When a system is not busy on a primary task, it may process background tasks. When applications are running as truly separate tasks, the system may divide the processing power into time slices and allocate the portions to each applications, just like preemptive multitasking. So the data may also be transferred between the programs, and it may be temporarily stored on a clipboard for later transfer or automatically swapped between the programs. So, all these are the characteristics of the graphical user interface, or what we expect from a graphical user interface.